So this question 8, I'm guessing it's part B since A was just stating the principle of moments. So this is a non-uniform plank or beam, and apologies for my messed up diagram, but the centre of gravity we're told is here, 30 centimetres from the end of the beam. Then we're told that it's pivoted at the midpoint, isn't it? Yeah, the plank is now moved and rebalanced at its midpoint. But earlier on you'd been told the full length was 80. So that means the midpoint is 40 centimetres along. Right. Okay. So centre of gravity is 30 centimetres from the end. It's balanced at the midpoint, which is at 40. And there's a 5 Newton weight here balancing it, and it is 8 centimetres from the very end. Now, if it's balanced, we know that anti-clockwise moments are equal to clockwise moments. So let's have a look. This 5 Newton one is making it turn clockwise, and the anti-clockwise has come from the weight of the beam itself. And that's what we've been asked to figure out. So this is the anti-clockwise one. But the distances that are on that aren't the distances that we'll have to use, because remember, it's always the distance from the pivot. So for my anti-clockwise, force times distance for the weight. Clockwise, force times distance for this 5 Newton one. So the force here for the anti-clockwise for the weight is the weight. The distance that we have to put in is the distance to the pivot. Now, if this is 40 centimetres from the end, and this is 30 centimetres from the end, then the distance that we're going to have to use there is 10, because the weight is acting 10 centimetres from the pivot. So weight multiplied by 10 equals, clockwise, the force is 5 newtons. And again, the distance they have given us isn't the right one. So from this end, this midpoint here is 40 centimetres from the end, but we were told that this was 8. So that means the distance to the pivot from that is 32 centimetres. So we end up with 10W is 160. So the weight is 16 newtons. Now I want to just do C while I'm here, because a few people have said that they are, oh sorry, it's part 2, it's not part C, struggling with that. Calculate the upward force which is now exerted by the triangular support. So there is going to be a force acting up the way here. Now the reason that we can ignore that whenever we're doing our moments calculation is because the distance from it to the pivot is 0, so it's not creating a moment. So I'm going to call that R, just because it is a normal reaction force. So for part 2, we can just use the fact that because this is balanced, because it's in equilibrium, all the upward forces must be equal to all the downward forces. So that upward force R has to be equal to the weight, which was 16, plus the 5 newton that was acting down the way. So we get 21 newtons, and that's where that comes from. Okay, hopefully this helps you. If you're stuck, I will stick it up on Google Classroom now. Bye!